In this video, I will be going over properties of logarithms. One of the properties is the product rule of logs. And this rule states that if you have log base b of x times y, that's the same as log base b of x plus log base b of y. So if we have multiplication, we can expand that into addition. Another rule is the quotient rule of logs. And this rule states that if you have log base b of x divided by y, that's the same as log base b of x minus log base b of y. So division becomes subtraction. Another rule is the power rule of logs, and this states that if you have log base b of x to the r power, that's the same as r times log base b of x. So when you have a power, you can bring that number to the front and multiply. Then there are the inverse properties of logs. So if you have b to the log base b of x, that is the same as x. And if you have log base b of b to the x, that is the same as x. And this is where b is greater than 0 and not equal to 1, and x is also greater than 0. We want to write this as a sum of logarithms. So we have log base 2 of 5y. And this is really 5 times y. So we can expand this to log base 2 of 5 plus log base 2 of y. And notice in the sum, they have the same base. And now we want to write as a single logarithm. So in this example, we start off with log base a of 7 plus log base a of m and here we can see they have the same base, which is a. And since these two logarithms are being added, we are going to multiply 7 times m. So we have log base a of 7 times m, which is the same as log base a 7m. For the next example, I have log base a of 2 plus log base a of x plus log base a of x plus 5. So here they have the same base, which is a, and all the logarithms are being added, so we're going to multiply. So we have log base a of 2 times x plus 5. And that becomes log base a of 2x times x plus 5. Using the distributive property, we get log base a of 2x squared plus 10x. And that's your final answer. Now for a quotient rule example, we want to write this log as a difference. So we start with log base b of y divided by 2y plus 5. Our y is on the top, so it will be subtracted first. So we have log base b of y minus log base b of 2y plus 5. And now we want to write as a single logarithm. So we have log base x of x squared minus x minus log base x of x minus 1. Here we see the base is the same, it's both x, and we have subtraction. So our top, or our numerator, is going to be x squared minus x, and our bottom, or our denominator, is going to be x minus 1. The minus sign will show us that we will be dividing. So now condensing this, we get log base x of x squared minus x divided by x minus 1. We can factor the numerator and we get x times x minus 1 on the top and x minus 1 on the denominator. Now we can cancel those x minus 1's and we're left with log base x of x. Or in other words, when we solve for this, it will be 1. Now for a power rule example, we want to write this logarithm as a multiple of a log. So we start out with log base 3 of x squared to the 1/3. So we can rewrite this as log base 3 of 2 divided by 3 of x to the 2 divided by 3. And then we can multiply that power to the front and we get 2/3 log base 3 of x. And now for the power rule of logs, we have -1/2 log base 3 of x, and we want to write it as a logarithm to a power. So our r is -1/2, that's what's being multiplied in the front. So we can bring that number to the power of x. And so we get log base 3 of 1 divided by x to the 1/2, since it's a negative power. And that's the same as log base 3 of 1 divided by the square root of x. And now we want to use the multiple rules to expand. So we have log base a of x squared times y divided by z cubed, all to the cube root. So that's the same as log base a of x squared times y divided by z cubed to the 1/3 power. The cube root is the same as the 1/3 power. So now we get log base a of x squared times y to the 1/3, and then z cubed to the 1/3, because we can apply this exponent to the top and bottom individually. Then we get log base a of x squared times y to the 1/3. And on the denominator, we'll just get z, because the 3 and the 1/3 will cancel each other out. And now we can apply the 1/3 to the x squared and the y. So we get log base a of x to the 2/3 times y to the 1/3. Because when we have a power to a power, we're going to multiply them. And now, since we have multiplication on the top, those two terms will turn into addition. And then the division part will turn into subtraction when we expand. So we have log base a of x to the 2/3 plus log base a y to the 1/3 minus log base a of z. Now we can multiply the power to the front, so we get 2/3 log base a of x plus 1/3 log base a of y minus log base a of z. And that will be your final answer.